Hey, it's Sukrit from STEMcoder, and today we're going to take a look at another property of derivatives, the scalar multiplication rule. Over here we've got a function f of x is equal to 3x squared. We do not exactly know how to take the derivative of 3x squared, but we can break f of x into another function and a scalar. We can break it up into a of x, which is equal to x squared, and b, which is equal to 3. And we can write f of x as b times a of x, 3 times x squared. So what is the derivative with respect to x of b times a of x? Let's find out. Up here we've got a standard limit definition of the derivative. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. We are going to replace f of x with b times a of x. So over here we've got b times a of x plus h minus b times a of x divided by h. And as you can see, we can actually factor b out of this whole thing. So this is the limit as h goes to 0 of b times a of x plus h minus a of x divided by h. Basically what I've done is I've just factored my b out of this expression, and we can actually take the b out of our entire limit expression. It's a property of limits. So this is equal to b times the limit as h goes to 0 of a of x plus h minus a of x divided by h. And what does this look like? Well, this is simply just a prime of x. So this whole thing is simply equal to b times a prime of x. So look at what we just found out. The derivative with respect to x of b times a of x is just b times the derivative of a of x with respect to x. It's a pretty cool rule, isn't it? We can basically just factor the constant out of the entire derivative. So let's write our formal rule down here. The derivative with respect to x of a constant c times a function p of x is just c times the derivative of that function p prime of x. And so up here, what is the derivative of 3x squared? Well, it's just 3 times the derivative of x squared, which is 2x. That's equal to 6x. I hope you found that helpful, and I look forward to seeing you in future lessons.